Hey guys, so today we're gonna kind of focus on and talk about gut microbial composition and how it really connects to feed efficiency and carcass outcomes in beef cattle. This topic sits right at the intersection of animal nutrition, physiology, and meat science, and the goal of this lecture is to help you build from our foundational beef production concepts that we'll discuss in the beginning, all the way to the active research linking the rumen microbiome to like what we actually see in terms of performance outcomes. First, we'll start with some economic and biological background, so how cattle use nutrients, how we measure efficiency, how carcass traits determine value. From there, we'll then move into the rumen microecosystem, how it contributes to cattle biology, and then we'll actually dive into two studies that here at the end of it that kind of help explain why animals differ and some differences that we see in terms of the rumen when looking at our efficiency and meat quality and yield. So, as we move in, the first thing that we really want to focus on is feed efficiency. We know that this is the most fundamental economic driver in beef production. And if you see here, feed is actually the largest cost in terms of beef finishing systems. Depending on the region and cost at the time and feedstuff, it can account for 60 to 75 of total cost in terms of production, which, as we all know, that's over majority, right? And so that means any biological factor that we can utilize to improve efficiency in terms of how cattle use feed can have actually a big financial impact into our producers. We typically evaluate efficiency using measures like feed to gain, gain to feed, and residual feed intake. And our residual feed intake, or RFI, is especially useful because it separates intake from growth, and efficient cattle maintain expected growth while consuming less feed. Efficient cattle lower costs without sacrificing performance. So understanding why these animals differ in efficiency is incredibly important. And today I kind of want to explore this route of in terms of the microbiome and see where does these answers lie and see if these microbial populations truly influence. So how do cattle convert feed into beef? Feed breaks down into nutrients, as we know, and those nutrients then go on to support growth, muscle deposition, and fat deposition. And what's important in this context is that different types of nutrients can lead to different types of fat. We know that intramuscular fat or marbling is formed and stored differently than subcutaneous fat or sub-Q or under the skin. And these pathways behind these two fat types do not operate in the same way. Marbling depends on energy sources that support glucose formation, while subcutaneous fat tends to correspond with other pathways. So this means the type of energy cattle derive from feed influences where the fat ends up in the body, and that matters because marbling and fat have completely different effects on the carcass, which then also influences the value. So what is beef grading? So we're going to take a step back in terms of this PowerPoint and really start to look at some of the basics here and start to explore areas of what I would consider actually to be probably one of my more comfort zones and what I really enjoy. And so since we know all of the cattle that we have in the industry are going to end up on the rail, as we see in this picture over here, this is actually during a meat judging contest. As y'all know, I'm the meat judging coach, and what we see there is those those carcasses hanging on the rail. And whether you be involved as a microbiologist or you're in repro or food safety or any types of things, especially those involved in the production of cattle, this is our end goal. And so if we're not truly understanding our end goal and how it's going to make us money, then kind of what's the point of some of those things in the other areas, right? And so beef grading gives us a standardized way to assess carcasses and price them fairly. Then within beef grading, there are two major grading categories: yield grade and quality grade. Yield grade is going to reflect basically how much product a carcass will produce for us, while quality grade in the basic terms is how good that carcass is going to look or how good that carcass is going to eat for us. Producers, packers, and buyers use these grades to determine premiums and discounts. And so, if we're trying to maximize profitability, we need to understand what biological factors influence both yield and quality. So if we compare the two of them here side by side, we see that yield is the percentage of closely trimmed boneless retail cuts from the round sirloin, loin, and chuck, or what we would consider part of like most of our primals there on that beef carcass. But if we want to break that down into even more layman's terms, how much retail product will be obtained? And so when I refer to retail product, I'm really referring to how much am I going to be able to put in the case at the grocery store? How much am I going to be able to put into front of a consumer that they can buy to then put on their dinner plate for their family or for themselves? Now, when we shift over to quality grading, we see that it focuses on the evaluation of traits related to tenderness, juiciness, and flavor for overall palatability. So, again, in layman's terms, it's how good of eating quality will it be for the consumer? I don't know about you, but I like my steaks tend to be more tender. I like for my steaks to be juicier and have more flavor. And as we know, most consumers also have that as well. And so we as producers need to find ways to drive that quality up, because we also know that driving this quality up is going to allow for us to actually make more money on the rail. So we're going to just dive down into yield grading, quality grading, because in case some of you have never heard of this or really talked about it in this class. And so for yield grading, we're going to do a range of 1 to 5 with numbers being like golf. So the lower the number, the better the cutability. So we would rather have a yield grade 1 versus a yield grade 5 because that just means there's more product available, which is going to equal out higher premiums for us and higher profitability in terms of when comparing them on the rail. That lower numerical yield grade again is going to be higher cutability, and like I stated before, it's like golf. Like it's sometimes it's not exactly what you think of. The higher we always think higher is better, but when we're talking about yield grades, we prefer the lower numbers there. So factors that go into yield grading is preliminary yield grade. So basically, this preliminary yield grade is going to be how much back fat is on there. So we have a conversion of inches of back fat to a preliminary yield grade. The hot carcass weight. So how heavy is that carcass? And then we also will be able to move into the ribeye area and look at some of the muscling factors. So the ribeye area muscling is probably going to follow the trends of that entire carcass. If we have a heavy muscled carcass, we're probably going to have a larger ribeye area. And then one of the ones that it may not be as applicable in our industry now, but it has always been historically is kidney, pelvic, and heart fat. And so as you can see, if you look at your yield grade equation over there, we start at the base of a 2.5 for our yield grade, and then we see that that back fat or preliminary yield grade is actually going to have our highest influence with the largest multiplier of 2.5, with KPH with a small zero point 0.2, hot carcass weight having little to no effect. But then see that ribeye area actually picking up a minus effect there with a 0.32 multiplier. So as we know, a heavier muscle carcass can help us have that lower number. So here, just real briefly, I wanted to show you some pictures of ribeyes of off of carcasses that I've taken over time. And so, as you see here in the first picture to the left, you see there's not a ton of back fat there, right? It's probably going to be a lower numerical yield grade, which means higher cutability. And as we move up through these carcasses, you see there on picture 4, starting to get pretty fat. And so we're actually going to have to take more time to trim that one down, cut off that excess fat. And not necessarily the excess fat is waste, but it definitely lowers the amount of profit that we're going to make with also having a higher input cost in terms of labor just to be able to handle that carcass and get it cut into how we need it to be for the retail case. So next we're going to go to quality grading, and I really want us to focus on quality grading today of thinking like which one should we really master because quality grading is what's going to truly drive a lot of our prices. And so you see here in bold, I have marbling because marbling is the key thing that we're going to focus on. So when I'm talking about marbling, we're talking about that intramuscular fat, so muscle within or fat within that muscle, and more is always better in terms of marbling. We can never really max it out. There's some people that they like one that maybe doesn't have as much marbling because they truly appreciate the flavor of beef. But if you look at this picture here, you see that ribeye right has a good bit of marbling. It's actually pretty trim, heavy muscle to be a really nice carcass. And so right here is what we were talking about with that marbling. The other thing that will go into quality grading is maturity. So briefly, you can have skeletal maturity. So we're just talking about age of the animal. You evaluate it by looking at its thoracic buttons, as you see in the picture to the side, and it can just kind of affect that tenderness, juiciness, palatability overall in terms of cattle. But the big thing takeaway here is our marbling, because when we started to discuss the microbiome here in just a few slides, we really start to see how that can truly affect the amount of marbling that we have in the ribeye. Some differences in quality grade here. So if you were a consumer and you were at the grocery store and you were wanting to decide which one you wanted to pick, I would hope that we would all choose the one all the way to the right. That thing is gorgeous, has a ton of marbling, it's going to eat really well. And then as we move from the right to the left, you see we start to drop in quality, right? We have less intramuscular fat or less marbling, probably going to have less eating quality there. And so as we move through those, we really need to focus on what is the consumer wanting? So what are we going to do as producers? So how can we alter the microbiome to get there? But why is this important? So if you're not involved in the cattle industry, you may not understand like what exactly these two go together with. And so basically more than half of the cattle in the United States are sold on what we consider a grid system. The grid is going to provide a base price, and then carcasses can receive premiums for things like high marbling or low numerical yield grades, or discounts for poor performance in terms of lower quality grades, or if they are fatter cattle that we're going to have to spend more time trimming or stuff like that. So all these traits we've discussed, like back fat, ribeye area, maturity, marbling, can directly influence the check that that producer is able to receive. And this is why we really need to transition our focus into why producers and researchers care about understanding what drives this variation, which is what we're going to talk about today. Of it, it could be that microbiome and some management things that we do for the microbiome that truly do drive what size check goes back into our producer's pocket. And so we're talking about side of the check, and I pulled this from an old presentation that I had, and I just kind of wanted to show you the values here. And so if you're evaluating, this is from a little over a year ago. We have our base value set there with a $295.71 for a yield grade 2 or 3 choice. But if you actually look and say we look at that very top left number there in terms of the grid, we see that there's actually a $17.55 premium for a prime, and even we have a premium there for our certified beef as well. And so if we look over onto the right side and look at it when it breaks out per hundredweight, we see just how much more valuable those carcasses that are of either higher marbling or higher cutability in comparison to its counterparts. So again, this just drives profitability, which we as the cattle producers and we as people in the cattle industry know is the final line of what we're looking for. So we talked about the background of the meat side, so honestly where my passion is, and I may have taken a deeper dive than I needed to, but I really wanted to paint the picture on that side of the industry and what we really are looking for and what we want, and really setting our expectations so we can understand the rest of this lecture. And so next are going to move into the microbiome, and as we know, it's a ever more popular theme. I feel like in today's world you rarely see a project that's involved with production that there's not a line written in there, or there's not any that don't have a line written in there for the microbiome and some type of analysis to kind of throw that buzzword in my opinion. And I actually looked this up just a few days ago on Google, and I narrowed the window down from the years of 2000 to 2022. And if we look at the spike in just the amount of searches the word microbiome has, and so even if you look in the last 10 years, that's when that true spike happens, where before 2012, we really weren't searching it. And so while this does encapsulate human microbiome and all of those factors as well, one thing we need to take into account is if we're starting to care about it as humans ourselves, we also are going to start to care about it a lot more in terms of animal welfare, cattle, and all of those above. And so it's something this I thought this graph did a great job of showing the relevance of the microbiome in our industry today and kind of where we're moving towards in terms of research and what we want to do for outcomes. So the microbiome, as we know, um, is just a massive fermentation vat. It's made of a super complex environment, made up of those bacteria, archaea, protozoa, and fungi. And we know these organisms work together to break down, if you remember back to one of those early slides, those feedstuffs into those nutrients that which is then going to be turned into the product that we have on the rail that we've already discussed. And so they're able to rely heavily on this. And if you look at this figure here, you see, as we know, that cattle are ruminants. They have that four-chambered stomach. And specifically today, we're going to look at that rumen microbiome, or there's a few studies we're going to look at that had the fecal microbiome. But as we know, like I said, they're made up of all of these different or this complex environment that's able to work together commensally in most areas and really drive efficiency and actually drive outcomes in terms of yield and quality as well. We know that the rumen is actually responsible for producing 70% of the energy that that animal is able to capsulate and utilize, and it's able to actually convert most of its feed stuff into 50% of the protein that that animal is actually going to use. And so, because we know that microbes determine how effectively feed is fermented, differences in microbial communities or populations can lead to pretty different, pretty big differences in terms of performance. So even if we have two cattle sitting in the same pen, sitting at the same feeder, eating the exact same diet, being managed the same way, if they are having that host animal has two different microbiomes, we know that this can actually drive quite a few differences between those two cattle, even though outside we would look at them and be like, those are two black cottage steers that are sitting there together. They should grade the same way. But as we know, there's a lot of different factors that go into that, with specifically today being one of those, the microbiome. So as we move into the rumen, I thought this was a cool figure to see. We just talked about all those factors that can affect it, right? And I'm not going to go into all of these because, again, we've talked about a lot of this in class, but just all of the different components that could affect the rumen microbiome. We see the host genome, the breeding, genetic selection, feed additives. So we've talked about some of those pre, pro, and postbiotics along with ionophores. Um, we talked about some intervention, so some manipulation or weaning strategies. And then specifically, as we know, the diet heavily affects the gut microbiota. So as the cattle transition from those forage diets to concentrate diets in a finishing system, we know the diet can have effect on that. And so as we move through and we look at kind of the importance of that microbiome, we know that, like I've said, that it converts this feed stuff to high quality. And it also, because of all these different individual parts and how important it is, it directly affects that host animal in both a positive and negative way in terms of efficiency and in terms of final outcome that they can have. So as we discussed the rumen, we're going to kind of, I feel like I've talked about it a lot, but specifically, I want to talk about the rumen specifically. So we talked about how that gut microbiota composition is diet driven. So according to how much forage we have in that diet or how much concentrate we have in that diet. But specifically, we know that that rumen is dominated by both firmicutes and bacteroidetes. What we do know is that the rumen functions as in ways of being able to ferment that biomass, so ferment what it's able to take in from plant products and produce the VFAs, which we're going to discuss here in a little bit. And then but we know that it also supports the metabolism and immune system. And we know without a healthy animal, we're not going to have the product that we want at the end of the time in terms of what we want to see on the rail that's going to make us money there. And so one thing that I like, well, you've seen this figure before with me, but I think it does a great job of truly breaking down the rumen and what it does, and especially looking at that particle size reduction there on the left to seeing we go from those large particles all the way down, and by doing this, we're able to truly get all that we can out of that plant material. We're able to get all the energy from those feed stuff that we're then able to take and put into different forms of fat, different forms of growth, and truly see what product we're going to have at the end. One thing that I want to talk about is the types of bacteria that we have. And so we have the amyloidic bacteria, which is going to kind of degrade that starch. And then we have, and some examples of that we have are Streptococcus bovis or Prevotella ruminicola. And then we have cellulitic bacteria, which is going to degrade that cellulose or that more like forage-based type product. And so Some examples of that will be our Ruminococcus albus or Fabrobacter succiniogens. And so we'll talk about this a little later in terms of looking at efficiencies across cattle, but really want to just highlight these two types of bacteria here. And then another factor that we're going to talk about and part of one of the studies that we're going to look at is diversity indices. And these can be confusing if you have not heard of them before, and I think we all kind of have a different way of explaining them. But basically, we're going to look at the alpha diversity, so looking at it within a sample from an animal. And the three that we're going to kind of focus on today are some variants of those that we're going to focus on today are the evenness, so the abundance of each individual species present. So if we look at community A over on the right, it's probably going to be more even in terms of it, and then comparison to community B or community C, because as we see, there are only three of each of those. So there's equal amounts, it's completely even. Second one we're going to look at today is richness, so the number of different species present. So when looking over at our three communities, we can say that community A and community B are probably the same in richness because, again, we're just looking at the number of those different species. So we see three different colors represented there, three different species. And then the Shannon index is actually going to have and take a combination of both evenness and richness. There's a few different indices here that combine those, but Shannon index is one that I feel like is pretty common. So just wanted to put that one out there in case you've heard that phrasing. And so now that we've went through a good bit of this background information, we've talked about what of how efficiency is important for our cattle, why we want them to be more efficient, lower input costs, greater output costs. We've talked about that to be able to get those greater output costs, we need to be able to have a greater quality grade and greater yield grade, the factors that go into that individuality. And then we talked about the microbiome, how it truly influences everything that I just discussed in terms of efficiency and grading, even though we may not directly think of it in terms of, especially on the carcass side, having such a great influence. And so to really drive this point home and talk about today, I actually pulled two different papers that we're going to kind of look at their studies and look at their results of what they saw in terms of how the microbiome affects cattle. And it's actually two papers that come out of two students that were actually in my live group during the past time. And so some of the studies here done at the University of Georgia. And so the first one we're going to look at is Welch et al. And it's the evaluation of the fecal microbiome of Angus steers with divergent feed efficiencies across the lifespan from weaning to slaughter. And so what makes this study unique is how we are able to look at this at all the different time points and comparisons there. And so first, we're going to kind of just quickly discuss the study design. And so there were steers that were evaluated over a course of a lifetime for RFI. So if you remember back to that first slide, that RFI is residual feed intake. It's just going to compare what we expect those animals to intake versus what they actually do and see if we're able to have efficient animals there. And what they did was they collected fecal samples at weaning, yearling, and slaughter times, and then they were able to take that back for microbial analysis and really dive into those there. So some performance data that we're going to look at first. So if you look down at the dry matter intake there, we see that those inefficient animals are eating quite a good bit more. So they're eating almost 4 kilograms more a day in terms of dry matter intake there in the feedlot. And as we can imagine, feed costs are not necessarily cheap. If you remember back to that first slide of it takes up actually 60 to 75%. So over a time in a feedlot, those 4 kilograms a day add up very, very quickly in terms of how much money we are putting into each of these animals. If you look next down, you see that feedlot feed to gain ratio. So for however many pounds of feed is there to the pound of gain. And as we see there, in the inefficient animals, it's or in kilograms today, but in that inefficient animals, it's seeing that we're taking 15.84 kilograms of feed to equal to 1 kilogram of gain. But then we look at our efficient animals, you see there with a 10.454 kilograms to every 1 pound or 1 kilogram of gain. And so I just wanted to put this performance data in there to really show the differences in this inefficient and efficient group before we start to dive into some of the other results that they have and kind of show truly just how divergent these steers were. So next we're going to look at several different bacterial families that we have here in terms of what they were able to evaluate and see some differences in. And the first slide here that we're going to look at, you see there's that these efficient steers had higher levels of Ruminococci and then the Christensenelliaceae. And I know I probably butchered those names, but we see that they have those graders ones here. And so we know that these are actually normally associated with fiber degradation. And so it's kind of unique and kind of cool to look at that you can see there in when compared to weaning to yearling to slaughter that in both our efficient and inefficient animals that it actually decreases, which we would expect. And since in terms of diet transitions, they're going from a more forage based at weaning and that backgrounding type phase to a more concentrate based diet there right before slaughter when they're in the feedlot. And you kind of see the same trend happen over there in the other. But one thing that I wanted to point out was, well, we may not think about it, but how I interpret this is that because those more efficient animals had more abundance of these fiber degraders, they were actually able to take advantage of some extra nutrients that maybe some of the cattle in those inefficient groups weren't able to take advantage of, even because we do know that most of our diets are TMR. There is going to be some type of forage base there. And so they were able to truly encapsulate any of that energy from that portion of the diet better than those cattle that were in our inefficient group. So the next two families that we're gonna evaluate is Bifidobacteriaceae and Lactobacilliaceae. And I'll be honest, this one kind of threw a wrench in things for me whenever I started to evaluate it because both of these are actually known starch degraders, and we would think that with these being a known starch degraders, that our more efficient cattle would actually have higher levels. And for me, if I take a step back and think about it, while they may be more significant, we may see these more so within those cattle there. One thing that we can see is from those top, especially in the Bifidobacteriaceae, is as we see over time, it does increase in both sets of our steers, even more so there in our inefficient steers as feed, but that kind of follows the trend of our diet and what we would expect. And kind of same thing there on the other side as our gut trying to starts to get used to the diet and kind of starts to regulate itself. And so one thing that I want to kind of talk about is in terms of those starch degraders. Um, we do know that it's not necessarily the amount of starch degraders, but at the rate of digestion of if those starch degraders are able to take advantage of it, the balance of the gut as a whole, if those starch degraders are truly able to have a significant level within the gut. And then also where it is in terms of fermentation of whether it be the rumen or the hindgut. And so that's kind of the reason that I threw this slide in here is while the science doesn't necessarily back up what we would normally think, as we know, the microbiome is the ever diverging area of research. And so as we continue to explore these avenues, we hopefully will start to find an answer and start to really explore this area and kind of see maybe some more answers in terms of it. So when we look at this study as a whole and start to kind of conclude it, although these bacterial populations truly fluctuate with diet and age of steers, we see that these certain bacterial families can consistently be higher or lower in our steers. And so that Ruminococci, Reichenelliaceae, and Christensenniaceae were higher in those efficient steers from weaning all the way to slaughter. Then that Bifidobacteriaceae and Lactobacilliaceae were higher in those inefficient steers during multiple stages of production. So one of the take-home messages that I want to be taken home from this first project is the microbial diversity was correlated with feedlot feed efficiency and found to be higher and more efficient steers throughout production. And so when we talk about this and we see this diversity is we're able to see that those animals with more diverse guts are actually able to take advantage of more of those feed stuff that are there. So was how I kind of the conversation I had there with those fiber degraders of why they were greater and are efficient animals is because they were more diverse. They had more options of kind of what tools were in their tool shed, right? They were able to take all of their tools up to the front line and figure out which ones of these can I break apart and which ones am I able to actually utilize. And so that's why these animals sometimes can be more efficient in terms of feed efficiency because they're able to utilize just more areas of that feed stuff, of that diet for energy to go into growth. So from here, we're going to look at another study that really looks at the relationship between the rumen microbiome and carcass merit in Angus steers. And so I talk about carcass merit, I'm talking about all those factors that we talked about at the beginning of the lecture with yield grading and marbling. And so the study design for it, where they utilize some beef crossbred steers or I'm sorry, so those Angus steers that we talked about, and they were broken into best and worst groups for grading parameters. So they pulled 20 steers for quality or marbling class is what they called it, and they chose the 10 best steers and the 10 worst. And then same thing with yield grade, they chose 10 of the best and 10 of the worst. And so when we start to evaluate it, that's kind of how we're going to look at them is the top end of those cattle and the lower end of those cattle. For alpha diversity trait differences, it's actually pretty cool that you were able to see some here in terms of marbling. And so in those high marbling cattle, there was more microbial richness and diversity was higher. And so if you remember back to richness, it's how many different species or how many different species are noted. And then that diversity again is combining some of those factors in terms of richness and evenness. And so again, kind of just to the same conclusion that we pulled from that last paper of these cattle with more diversity in terms of their guts are having better outcomes for us. And so, excuse me, and so um as we can see that these cattle are able to really take advantage of some more of difference of these traits and actually able to turn these into better outcomes for us in carcasses. So if we start to look down into some bacterial families, the first one that we're going to evaluate here is the S24-7, which they noted was greater in high marbling animals. So as you look over there to the side, you can see the relative abundance of that family, right, is a good bit higher there in higher marbling cattle. And this actually pretty cool to look at because it supports previous literature that suggests this bacterial family is known for degradation that results in propionate. And as we know, propionate is our glucogenic VFA. And so it has been directly linked that higher propionate production leads to higher levels of intramuscular fat or that marbling that we talked about at the beginning of the presentation, which then again is just going to lead to a higher output cost because we're able to sell that product for more. Another one was the greater abundance of Christina senilacea in better yielding animals. So we're swapping from quality over to yield. So we're swapping from looking at how good that thing is going to eat to how much product is it going to give me. And so, as you see here, it was significantly greater in our better yielding animals. So there was a greater abundance in those animals, and it's actually consistent with a reoccurring link that is known in human health, where these greater abundances of this species are actually, seen more so in people that have a normal BMI. So people that are more in shape, they have maybe a normal muscle mass, not as much fat on them, which we can translate over into being to our better yielding cattle, where they're going to be heavier muscle, they're going to be trimmer, and have more product for us available to make money off of. The next one that we're going to look at is Corynebacteriaceae, and so it actually has lower abundances in those carcasses with the better yield grade. So less of this was found in the ones that were on those higher yielding animals. And this is logical given the association that we see in literature between these families and acetate production. So lower abundances of these bacteria may result in less acetate produced. So again, one of our BFAs, which is ultimately resulting in less subcutaneous fat. And so when we think of that subcutaneous fat, again, we're thinking of some of that external fat. We're thinking of the back fat or the preliminary yield grade that we discussed earlier. And so when we have lower abundances of these, we have less back fat. If you remember back to that equation, back fat actually had the highest multiplier. So it's going to have the most effect on our yield grade. So this could directly affect truly how much product we're able to make and how much money able to make in terms of the grid system. So when we think about the study conclusions for this project, we see that abundancy and diversity of bacteria contributed to differences in cattle performance. Again, we see the abundances of different families, whether it be greater or lower, that it can truly have effects on our cattle. And then the diversity as well. Of again, just kind of that take home message of that cattle are able to, with the more diverse guts, have more tools in their shed to be able to attack the day. We see that those more efficient steers consistently showed higher populations of key fiber degrading families, and I truly do chalk that up to saying that they were able to utilize more of their diet because they had those greater amount of key fiber degrading bacteria to truly take advantage of those forage-based type forage-based type ingredients that were included in their total diets and their TMR, especially there during the slaughter phase. And we see that again, microbial diversity aligned specifically with improved efficiency and performance across all of the production stages. So across uh, and all the way to slaughter, we see that more diverse guts tended to lead to better efficiency and better production. So microbiome and carcass merit, as we saw, like the bacteria associated with propionate production was higher in better marbling steers. To me, this is a direct link that makes complete sense if we think about propionate as our glucogenic BFA, and we know that it's directly tied to marbling, right? So if we have a greater abundance of those bacteria, the ones that are going to create propionate, this means that we will directly have a lot more propionate available for the animal to use for the animal to take advantage of. That animal has a lot more of it to take advantage of. What that means we'll have excess of it in terms of our marbling. We again, like I stated at the beginning of this presentation, can truly never have excess of marbling in terms of where we at in terms of an industry that people are going to search for that quality grade. They're going to buy for that quality grade. And so this is a super cool thing that we as cattle producers and we as researchers can really look at is truly looking at that linkage there between propionate and marbling within the ribeye. Families connected to acetate production aligned with poorer yield grades. So again, we just talked about that, right? Of those families that were with propionate, or not propionate, I'm sorry, with acetate, tended to be linked towards more of the sub-Q type fat, that external fat, and so more of that is going to lead to more sub-Q fat. And I don't know about y'all, but most people don't like to have a steak that's got an inch of fat on it, and so we're going to have to spend more time there. And so we're just gonna have decreased performance overall. We're also probably gonna put more feed into that animal to get it to a weight that has just more fat weight than muscle weight. And so those poor yield grades are truly gonna take a cut for us at the rail. These microbial shifts can help explain the differences in quality and yield outcomes. So this is really just taking those and saying, like, in terms of those efficient and inefficient steers, the shifts between those of when we're putting them on feed, when we're going through different management practices, what we can kind of do to really influence those cattle and what they need. So, some of the biological mechanisms that, as again, this is the kind of the key takeaway. So, it's some repeats of what we just discussed is that there's really unique groups of bacteria support different metabolic pathways. And so, while we may think of each of those bacteria as a very small percentage of the rumen or the very small percentage of those cattle overall, we know that they each drive a different metabolic pathway, which has a different outcome, which one outcome leads to a bigger one, and then finally we're able to look at those economic outcomes on the rail. Again, the propionate leaning microbes tend to go towards more of that intramuscular fat or that marbling that we really drive for in the industry. And then we see that acetate leaning microbes really going towards that sub-Q fat and having the most of that yield grade impact. And so these are really explain why specific families appear consistently across these two studies because we were directly looking at, if you remember, the best and the worst in terms of marbling and in terms of yield grade. And so, in comparing those extremes in the study, we would expect to truly see some differences in the abundances of bacteria families that would lead to these differences that we see here. And so, some big picture key takeaways that I want to discuss is that, again, as we know, just kind of recap the very beginning of this presentation, that remember that yield grade and quality grade are both going to drop our profit very, very much. And so we've got to find ways as cattle producers and researchers to truly, truly make it easier, not as much easier, but make our cattle perform at a better rate to where we are able to make more profit off of these animals and continue to build the industry that we're a part of today. So one of those ways that we could explore that is the microbial composition, because as we know, it's such an important factor in feed efficiency and carcass value. In just the past few years of grad school and even in times of undergrad, I mean, just the amount of talk about the microbiome, as you saw again in that figure from the Google search, but also just the amount of knowledge that we have learned from the microbiome thus far is always growing. And so I think in these next few years, if we truly continue to explore microbial composition and its effect, we'll continue to find a ton of pathways and a ton of differences that can affect our bottom line in terms of cattle producers and find ways to truly implement it back on the farm. The second one here is that we know that diet, again, has a huge influence on that rumen microbiome. We know that age can actually have some difference. So as those cattle mature, as those cattle spend more time on different types of feed, and then especially management as well. So how are we managing those cattle? How are we specifically feeding them? How are we handling their stress levels to make it to where that rumen is staying happy and healthy so that we are able to get the most out of that animal? But one thing to take into account is while all of these shape that microbiome, it doesn't really erase those core efficiency related patterns that we see. And so we're always going to have those core groups within the rumen that cattle have, and they're able to have been ecologically taken advantage of for years, and they'll continue to take advantage of for years. However, the biggest thing is how can we actually influence that through these different managements such as diet and a or diet and just some different management levels there, because while we may not always directly change the core, what we can do is change how they interact with each other, maybe change some of those smaller guys in terms of the microbiome and really see if we can drive different efficiency patterns there. So with this, we can see that understanding these microbial signatures, so understanding all the way these guts are built and what exactly they do for each of us can help us in better selection. So as we move forward with cattle, if we can start to select for cattle that are higher efficiency or have a certain microbiome composition that looks more towards efficiency or looks more towards those better outcomes, we can select cattle that are in of a genetic makeup or genetic bloodline that are like that, or whether it be even a phenotype that we see that cattle are hardier, they perform better when they're built like this, look like this. It can truly help us to continue to better the cattle herd that we have in terms of the United States today. Second one there with management. I mean, as we know, there's a ton of different management styles if we look across the beef industry as a whole. And so if we can identify those management styles that truly help the microbial side of things. So again, we know how the gut works. We know the gut is like the second brain of that animal, right? And so if we can manage, say, their second brain, if we can manage it better to be able to get it to think how we want it to think and do what we want it to do, we can truly drive that in terms of that yield grade and quality grade differences that make us money. And then we can actually use it as prediction tools as well. So one thing I thought that this was pretty cool in terms of prediction is that we we could actually take samples from these animals at one point and we could kind of look and we could predict and see where do we think these animals are going to line up in terms of efficiency. And this may even could become a tool in terms of sorting cattle. We could sort cattle into pens of animals that we believe are going to be higher efficient animals or lower efficient animals, and have them with their counterparts, and then we know we need to manage those animals differently to get the same outcome on them. And so, again, this all just kind of leads into each other. Of if we're able to predict these animals, we're then going to be able to manage them different, select for them differently, and truly make more profit. And so, to finish out this presentation, again, like I know that this was probably a bigger overview type presentation or lecture that we went through today, and we may have looked at some more of the basics in the beginning. But one thing that I believe that we as researchers in the cattle industry and as people that are relaying information to our producers is we can't forget the basics, because if we forget the basics, we forget the big picture in the end. And as we know, the basics is just that managing those ruminant animals to be more efficient, to have us have less input and more output. And if we don't truly understand that end picture there at the end of truly what how we make our money in the cattle industry and how we're able to be profitable there in terms of yield grade and quality grade, we're going to lose the vision of the cattle industry. And so I'm a huge advocate of that. If you're involved in the beef industry in any avenue, you should go and experience the beef plant at least once and truly see that side of things, because it really puts into perspective of how we truly can make the cattle industry better. And I think when we look at this lecture today, we look at the differences we've already noticed in the past few years of how the microbiome can directly affect the carcass and direct efficiency. It should excite us as cattle researchers of where we can go in the next few years and how we can truly make our cattle better. So, again, key takeaway today is while those little bugs that are in that room and might be small, and we may not think of them as truly that big and impactful, as we see, they can actually affect that bottom dollar in multiple ways, whether that be through the efficiency of that animal, whether that be through the yield grade of that animal, or even whether that be through the quality grade of that animal. So if you have any questions, or I know I kind of rambled on several of these slides, you just like want to talk to me about some of them more, feel free to reach out. I'm more than happy to discuss this and really talk about the side of the industry that I've grown to love. So thank you all for listening, and hope you got something out of it.